Okay, 3.5 notes, derivatives of trigonometric functions. So for trigonometric functions, we must be in radian mode. Okay, so in class today, we found that d dx of sine is cosine of x, and the derivative of cosine is negative sine of x. We can use these derivative formulas in conjunction with all of our previous derivative formulas. So our first one being the power rule, right? The derivative of a power, we bring down the n and we multiply that by x and subtract n by 1. The product rule we know is u times v prime plus v times u prime. And for quotient rule, we know we have v times u prime minus u times v prime over v squared. So we're going to use cosine and sine in conjunction with these other formulas to help us with these notes. Pardon the music and the sounds. I'm recording this right under a classroom that seems to be having a dance party upstairs. So we are going to do these two practice problems. So for the first problem, we have 3x to the 5th times sine of x. So here we have two functions multiplied by each other. So our first function, the 3x to the 5th, I'm going to call that u, and sine x I'm going to call v. So u is 3x to the 5th, u prime will be 15x to the 4th, v is sine x, v prime will be cosine x. So then product rule says take u, which is 3x to the 5th, multiply that by v prime, which we said is cosine of x, then add u prime, which is 15x to the 4th times v, which is sine x. And we can't simplify this any more than it already is, so this is our final answer. So now, using quotient rule, we have a function divided by a function. So I'm going to take the top function as u, the bottom function as v. So then u is cosine x, u prime is negative sine x, v is 1 minus sine x, and v prime, derivative of 1 is 0, derivative of sine is cosine, and it's negative, so we have negative cosine x. So then, when we do our quotient rule, we have 1 minus sine of x times u prime, which is negative sine x, minus u, which is cosine of x, times v prime, which is negative cosine of x, all over v squared. So 1 minus sine x squared. So we could multiply this out. We would get negative sine x plus sine squared x plus cosine squared x all over 1 minus sine x squared. And we can just leave that the way that it is. So that's how we would use sine and cosine in conjunction with our derivative rules to solve some derivatives. The next page we are going to use sine and cosine in the derivatives to find the derivative of tangent, cotangent, secant, and cosecant. So this first derivative that we are finding on page 2 is 4 sine of x divided by cosine of x, which we know is the same as just finding the derivative of tangent of x. So in this derivative, we have a u and we have a v. Sorry, the focus on this is really terrible today. So sine is my u, cosine is my v. So my u prime is cosine of x, and my v prime will be negative sine of x. So I'm going to try and focus this a little bit better. Okay. Alright, so we're going to use the quotient rule to help us determine the derivative of tangent. So we have cosine x times cosine x minus sine x times negative sine x all over cosine squared x. Okay, so when you learn trig identities at some point, you learn, or you should have learned, that cosine squared x plus sine squared x is equal to 1. This is one of the trig identities that you should have learned when you were learning trig identities. So when we simplify this top row, we have cosine squared x, negative and a negative makes positive, so plus sine squared x all over cosine squared x. So the top is now going to reduce to 1 over cosine squared x. 1 over cosine we know is secant, so 1 over cosine squared is 1 over secant squared x. So the derivative of tangent is 1 over secant. Oops, sorry, not 1 over secant squared. The derivative of tangent is secant squared x, because 1 over cosine is secant. My apologies. For the second one, we have cosine over sine, which we know is another way of writing cotangent. So again, we have u and a v. So our u in this case is cosine. So our u prime is negative sine. And our v is sine. So our v prime is cosine. So when we put this into our quotient rule, we will have sine of x times negative sine x minus cosine of x times cosine of x all over sine squared x. So up top we have negative sine squared x minus cosine squared x all over sine squared x. And using our identity, again, cosine squared x plus sine squared x equals 1, we can pull this out, and that's the same as saying negative 1 over sine squared x. 1 over sine is cosecant, so negative 1 over sine squared will be negative cosecant squared of x. So the derivative of cotangent is negative cosecant squared x. For our last two, we have 1 over cosine, which we can break down to just being secant. And then under that, we have 1 over sine, which is just cosecant. And we're going to use the quotient rule 2 more times to figure out what those derivatives would be. So here we have 1 is u, cosine is v. So u is 1, u prime is 0, v is cosine, v prime is negative sine. So if we put them into our quotient rule, we have cosine of x times 0 minus 1 times negative sine x all over cosine squared x, which is equal to sine of x over cosine squared x. So cosine squared x means that's cosine times cosine. So we can split this fraction so that it is 1 over cosine times sine over cosine. If you multiply those two fractions, you get sine of x over cosine squared of x. And these boil down to secant x times tangent. of x. So the derivative of secant is secant x times tangent of x. And something similar happens when you take the derivative of cosecant. So our 1 is our u, our sine is our v. So u is 1, u prime is 0, v is sine of x, v prime is cosine of x. So then we have sine of x times 0 minus 1 times cosine of x all over sine squared of x. So this comes down to negative cosine x over sine squared x, which we can split to negative 1 over sine x times cosine x over sine x. And this comes down to being negative cosecant x times cotangent x. So down at the bottom, we found the derivative for tangent. That was secant squared x. Derivative for cotangent was negative cosecant squared x. Derivative for secant, which was secant x tangent x. And the derivative for cosecant, which is negative cosecant x cotangent x. Okay, so on the last page of the packet, we're going to use these derivatives to solve some problems. So the top of page 3 summarizes the derivatives that we just found. And we're going to use that for number 1 to help us find the second derivative of secant x. So we know that the first derivative, dy dx of secant x, is equal to secant x times tangent x. So we're going to use that and product rule to help us find the second derivative. So our second derivative will be the product rule using secant x being u and tangent of x being v. So my u is secant x, so my u prime is secant x tangent x, my v is tangent x, so my v prime is secant squared of x. So we should have secant x times secant squared of x plus, I'm running out of space going along, so I'm going to write it down here, plus tangent of x times secant x tangent x. And when we simplify this, secant times secant squared should give us
Okay, so when we simplify, we get secant times secant squared, which gives us secant cubed. And then down here, we get tangent times secant times tangent, which gives us tangent squared x times secant. And that's our final answer. Okay, so for our last problem, we want to write the equation of the line tangent to the graph of y equals tangent x over x at x equals pi over 4. So first thing we want to do is find the derivative of tangent x over x. So I'm going to make tangent x u and x v. So u is tangent x, so u prime is secant squared x. V is x, so v prime is 1. So when we set up our formula, we have x times secant squared x minus tangent x times 1 all over x squared. So that is my derivative, that is y prime. So if I want my derivative at x equals pi over 4, that means I'm finding my slope when x is pi over 4. So my slope of my tangent is going to equal pi over 4 times secant squared pi over 4 minus tangent of pi over 4 times 1 all over pi over 4 squared. Alright, so using unit circle, I know that secant of pi over 4 is the square root of 2, and if I'm squaring that, then we have 2, so then we have pi over 4. Secant squared of pi over 4 is 2 minus the tangent of pi over 4, which is 1, all over pi over 4 squared, which is equal to pi over 2 minus 1 over pi squared over 16. Which is equal to pi over 2 minus 1 times 16 over pi squared, which reduces to 8 over pi minus 16 over pi squared. So that is the slope of my tangent line.
And to write my equation, I know my x is pi over 4. My y is going to be the tangent of pi over 4 over pi over 4, which is equal to 4 over pi So I have my x, I have my y, I have my slope. I just need to now plug it into my y minus y1 equals m times x minus x1. So we have y minus 4 over pi equals 8 over pi minus 16 for pi squared times x minus pi over 4. And that is the equation of that tangent line. That's all of the notes for today. You will get a problem set in class tomorrow that you will work on and will be due on Friday.